All right. I'm a little taller. Well, I just moved the laptop up. Looking for evidence of much greater river activity in the past, which might point to a worldwide flood, not just a few local floods. So we go to this address here, K39, and look for evidence of much greater river activity. And we struck out. Interesting. Sometimes you do a search, keep it simple. Evidence of much greater river activity in the past is another thing that seems to point to a worldwide flood, recent creation. The rivers of the world universally give evidence of having once carried much larger volumes of water than do their present remnants. This is evidenced by the raised river terraces nearly always found along their courses and by the extensive deposits of alluvium along their floodplains. These terraces are so common that an entire terminology has been developed attempting to categorize them in different types on the basis of their assumed evolution, forcing the issue again. Well, here we go. C.A. Cotton. Many streams are actually called underfit streams because the valleys they traverse are much too large to have been constructed by them. If a stream, or more correctly, the size of the stream meanders, is too small for the size of the valley, the stream is said to be underfit. If too large, it's referred to as overfit. It is difficult to cite examples of overfit rivers or streams with floodplains too small for the size of the stream. Hence, there may well be a question of whether overfit streams even exist. So why put them in the textbook till you found them? The underfit condition can persist indefinitely, hence many examples of such streams exist. Interesting. Dry stream channels. Similarly, there are many examples known as of former stream channels that are now completely dry. Some of these, of course, have resulted in the shifting of channels, but many others were evidently formed by streams that no longer exist, except perhaps in greatly reduced volume as subsurface streams. These are especially common in the glaciated regions and of course are usually, but not always accurately, attributed to formation by glacial meltwaters. But they are also found in the non-glaciated regions. Ever considered a worldwide flood? And also, another point, certain sand and gravel deposits indicate former existence of great rivers. In addition to sand and gravel deposits are found in many places that indicate the former existence of great rivers whose valleys now are buried by the later glacial deposits. Notable example of this, so-called TERRACE River, which once coursed across the continental United States nearly from the Atlantic to the present Mississippi, where it debouched into a far northerly abatement, formation of the bay of the old Gulf of Mexico. This is truly a mighty river in every sense of the word. It was this valley that Tite long ago recognized as the abandoned course of a great river. Thick beds of sand and gravel, including water-worn boulders up to 12 inches or more in diameter. They lie upon the valley floor. Many, composed of rocks quite dissimilar to the bedrock of the valley, show unmistakably that they were washed by river action from the bedrock region of the Blue Ridge. Only a great and powerful river could have accomplished this. So the TERRACE River, ancient precursor of the East, spoken of here by Raymond Jansen. This great river probably represented a channel developed by the retreating floodwaters in response to the uplifting of the present Appalachian region. With its huge load of sand and gravel and boulders, it could have scoured out its great channel rapidly and also carried an immense amount of alluvial materials to initiate the formation of the Mississippi Delton region. With its great network of tributaries, it helped carve the landscape of a large portion of the continent. The amount of sediment, mud, silt, sand, and pebbles, which it eroded and carried to the sea must have been tremendous. The sea into which it poured those sediments was the long, narrow arm of the Gulf of Mexico. This long seaway from southern Illinois to New Orleans has been completely filled, and the great delta now juts far into the Gulf proper. It seems evident that the greater bulk of the delta was built by the T's, with the Mississippi adding only the latest portions. Hence the immense delta, more appropriately, might be called the delta of the T's. Now, glacial geologists believe that the continental glaciers that buried the T's and other such streams under a thick deposit of silt and completely changed the greater drainage pattern when they retreated. Valleys and rivers evidence much greater river activity in the past as well. But it is the present valleys and rivers which appear to give the strongest witness to the former existence of much larger rates of river flow than now. Evolutionists von England and Castor deny that there could have been a greater river flow in spite of the evidence. Seems to be what they do more than not. In a stream valley, the width of the channel occupied by the current may only be a small fraction of the width of the valley floor. Further banks, the banks of the channel, are regularly low compared to the height of the valley sides. In a word, valleys commonly appear to be far too large to have been formed by the streams that utilize them. It happens too often. A first thought is to infer from the stream that the stream was once a much greater current. This almost always proves to be an unreasonable conclusion because no evidence can be found that a larger volume of drainage was ever available. If, as indicated, England and Castor, the reason for rejecting the plain indication of a former much greater stream flow is merely the lack of a source of the required waters, we would suggest that for consideration once again, the waters of the flood, which in response to the uplift of the lands and subsidence of the ocean beds, required to be rapidly and powerfully transported to the sea. Furthermore, the rainfall of the early post-Diluvian times must have been much greater in most places than it is now. So much evidence, worldwide flood. Raised river terrace evidence higher level and volumes of stream runoff. Similarly, the former higher levels and volumes of stream runoff are shown by the raised river terraces. But in like manner, this evidence is commonly and falsely explained away by evolutionists as caused by various complicated processes of geomorphic evolution. Most large stream valleys are deeply filled with alluvium and exhibit well-developed raised terraces more or less paralleling their present slopes. These conditions are, of course, exactly what would be expected on the basis of the biblical descriptions of the tectonically induced retreat of the waters after the flood. Nevertheless, they are commonly and falsely explained by evolutionists on a strictly uniformitarian basis. Thus, old river terraces are falsely attributed to gradual formation of a flood plain by lateral planetation, that is, by the meandering of the river back and forth across its valley, gradually eroding the valley sides and smoothing out the valley floor, contrary to the laws of hydrodynamics of moving bodies of water. Then, the evolutionists must insist that rejuvenation of the river somehow takes place so that it begins a down-cutting action again violating the laws of hydrodynamics, which demand bottom cutting first before erosion of the riverbanks, leaving its former floodplain perched above its new as a raised terrace. It is plain that there is little actual evidence of these extensive lateral corrosion of streams, especially when cutting through bedrock. Alluvial streams, such as the lower Mississippi, of course have a wide meander belt, but they are cutting into an alluvial fill and not bedrock, which had already been deposited by earlier flows of greater magnitude, so that the floodplain itself is basically a plane of deposition rather than erosion. Consider this: if rivers that flow across floodplains many times wider than the meander belts are observed, it will be found that in relatively few places are the streams actually against and undercutting the valley sides. This suggests that there may be a limiting width of a valley flat beyond which lateral erosion becomes insignificant. The valleys of many, if not most, of the world's large rivers are so deeply filled with alluvium that it may seem inappropriate to consider their floodplains as veneers over bedrock valley flats. The alluvial fills in such valleys as those of the Mississippi, Missouri, and Ohio in places are several hundred feet thick. Thornberry says, thus the lateral corrosion hypothesis of river terrace formation appears to be mainly a uniformitarian assumption rather than an actual present geomorphic process. The Mississippi and its terraces have been studied probably more than any other stream, and, although a complex history has been falsely deduced for it, the evidence strongly refutes the notion that its broad valley could ever have been eroded by later planetation. Russell, long student of Mississippi Delta geology and now dean of graduate school, Louisiana LSU, states, broad floodplains are characteristics of most rivers leading to the sea. But many years these were explained on an erosional basis. The rivers were pictured as having cut down their valleys to a base level established by the sea, after which their energies were directed toward lateral corrosion or valley widening. The alluvium of floodplains was thought of as a thin veneer resting on laterally planed bedrock. Within more recent years, however, the alluvium of many of these floodplains has been penetrated by borings, which in practically all cases reveal valley fill, which is many times deeper than the deepest pools scoured along the river beds. In the case of the lower Mississippi Valley, the character of the bedrock topography which underlies the alluvium is comparatively well known and contains river trenches several hundred feet deep, while the river is rarely over 60 feet, and in no cases as much as 200 feet deep. Richard Russell, Instability at Sea Level. That these extensive alluvial deposits, not only in the Delta region, but also along the continental shelves, required a tremendous river to erode and transport and finally deposit them, seems as obvious as anything could well be. By all odds, the most reasonable explanation of these things is that one or more great streams initiated by the post-deluge uplifts and perhaps later augmented by glacial melting laid down these alluvial fills after carving the Great Valley, and then in response to intermittent uplift toward the north, left the present raised terraces. The terraces all tend to converge as they approach the Gulf, the oldest terrace being the highest and therefore reflecting the period of greatest discharge. Furthermore, the terraces are as difficult to explain in terms of supposed former higher sea levels, which evolutionists also propose. So consider this: most of the evidence in favor of higher sea levels is supposedly provided by terrace and shoreline features which now occupy elevated positions. But the alternative possibility exists that continental margins and interiors have actually risen positively rather than sea level. If there were freshly created shoreline features,